Here. For number 1, circle the direct variation equations. Remember that direct looks like this. Y equals ax. Which of these are in that format?
The last one.
The last one, definitely. There's one more. Not 5 over x. This one. Because we could rewrite that as y equals 1/5 x. So the second one and the third one were your answers there. Okay, on to number 4. State the inequality that is graphed below. So we're looking at this. We can see, is this shaded above or below? Above. Okay, so that's going to be greater than or equal to. It's a dashed line.
So it's not equal to.
Correct. And then we have to find the slope and the y-intercept. So y is greater than, let's start with our slope. Find points that it would cross the grid lines exactly. 2 over 3, x, and then our y-intercept, plus 3. And that would be our equation, our inequality. Questions there? Did you have a question? Go get your calculators and put your phones away. But for this, so we talked about domain range notation. We talked about how to write the equation given different transformations, how to write the equation given the graph, and how to write the transformations given the equation. So all of that is connected. Today we're just going to graph the absolute value and quadratic functions. You'll be able to use your calculator. You can do it without the calculator and then double check it, or just use your calculator. I wouldn't know the difference. But we do need to find the vertex. So that's not something we practice here, but when we were doing quadratics. These are all in our vertex format, so we should be able to easily find our vertex. Remember that that's your, it's going to be in the form xy as we write it. But in our vertex form, that's HA. So our transformations are going to help us determine where our vertex is. Then we're going to use our parent functions to help us graph it, and then we're going to confirm our details, our graph, in the calculator. So here, we have 2 things that are happening. Think back to our transformations. What 2 things would be happening?
Deduct to the right one.
I'm just so we can practice our transformations. Vertical shift up to and horizontal shift right 1. This part is not necessary, but if it helps you visualize what's happening, we can write that. Normally, if there are no transformations, where is our vertex usually? At 0. So if it was at 0 and it's going up 2 to the right 1, it's now here. Once we have that, we can look and see, do we have any A values that would change how this would look? No. So that means it's going to be graphed the same. If we know it's graphed the same, we're going to go up 1, right 1, and keep doing that. Plot at least 5 points on each side. And then go up 1, left 1. Make sure it's even. You don't want a lopsided V. And then draw arrows through that. Connect them and draw arrows through that. And I misplayed the vertex. So whether you put the vertex first, after you find your transformations, once you find your graph, it doesn't matter. But what would that vertex be? And you can use that from your equation, from your transformations, from your graph. Look at that lowest or highest point, it doesn't matter. But for this, you just need to graph it correctly and find the vertex. Questions there? Alright, we're going to double check that in the calculator. Go ahead and type this into your y equals. If there's anything in there, clear it out. Your absolute value bars is an alpha window. X minus 1. So type that in. You can either look at the graph or look at the table. I'll look at the graph first. That looks like mine, but I just want to double check. So I'm going to go to the table, and then I'm going to look at my points. My vertex I had was at 1, 2, accurate, and then I'm going to 2, 3, 3, 4, 4, 5, 2, 3, 4, 5, so on and so forth. And then the other way, 0, 3, negative 1, 4, negative 2, 5, 0, 3, negative 1, 4, negative 2, 5, and so on and so forth. So just use it to double check yourself. Or you could put it into the calculator and find it like that. Either or, it doesn't matter. Questions so far? For the next one, we're going to use the calculator and then write transformations and vertex from there. So you can see that both methods work. Okay, go ahead and type that into your y equals. Just don't forget the square. Type this into your calculator. Type this into your calculator. Everyone type this into your calculator. And then go into your table. Second graph. That's what I thought I did anyway. And then, just like before, we're trying to find where your y values repeat and find the middle. What is that middle? So that should be our vertex. Write that down and plot that point. And then you can start graphing the other points. You may not be able to graph all of them. So we have negative 3, 0, negative 4, 2, and negative 2, 2. You want 5 points, so maybe extend your graph or just plot these off the graph. Negative 5, 8, and negative 1, 8.
I can't see that far.
I'll show you.
I got the wrong place.
Oh, you have to open it.
I gotta wait for close.
Give it another week. 3 weeks.
I graphed those at the wrong
How's that
points originally.
I'll separate.
And then connect that. This is a quadratic, it's squared, so that should be more U-shaped than V-shaped, but it's very narrow, so it kind of looks like a V also. So looking at my vertex, looking at my graph, I can see that this did what? What transformations happened?
It moved left
Yes, how much?
3 times.
Okay. It moves to the left 3. You can see that either from the graph or from the vertex or inside. What else did it do? Not compressed.
Stretched.
It stretched. It vertically stretched because of that 2. I can also see that distance is no longer 1. It's now 2. So whether you look at the calculator and graph it and get the vertex, or look at this and get the vertex and then graph it, it does not matter. Questions there? We're going to do another one before lunch, and then maybe one more when we get back, and then you guys will practice them. Let's do number 4.
That's approval.
Nope.
Do we want want to do calculator first or find the vertex by looking at it first? Calculator, okay. So go ahead and type that into your calculator. Go into the table, second graph, and find that vertex. Find where your y values repeat, find the middle. Where would that be? 0, 1. And then we're going to graph the rest of these points, plot at least 5 points. So we go negative 1, 2, and 1, 2. And negative 2, 5, and 2, 5. I'm going to just go back and rewrite these transformations. Just so we have them. What happened here? What transformation? Vertical shift up 1. If you had just been doing that from the equation, there's nothing inside parentheses, so that will tell you your x or h value is 0. And then there is a k value or y, so that would be 1. Right, when we get back, we'll do one more if need be, and then you guys will practice some. Literally. Okay, we're going to do number 6. Do we want to do this in the calculator or by the equation? Okay, by the equation. Those that say calculator, do that.
Calculator. I need practice. I need practice.
It doesn't matter either way. You can still put it in the calculator. If we're looking at this and we're trying to find our vertex, what would our h, what would our k value be?
0.
0 for both, because we don't have one. What transformations happen with this negative? What is that doing?
It's flipping it over again.
Flipping it upside down. So that means it's going to look similar to this, the points wise, but just upside down. So that means instead of up 1, left 1, it's going to go down 1, left 1. And then to the right 2, and down 3, 4, sorry. And then to the left 2, and down 4. And then if we wanted to check that, you could put it into your calculator. This should be your vertex, so let's do that really quickly. So that my graph matches. If I go into the table, it starts at 0, 0, negative 1, negative 1, 1, negative 1. We did that. Negative 2, negative 4, and 2, negative 4. We did that. Questions on how we find the vertex, how we graph these? I want you to do numbers 3 and 5. Do that before you move. Listen. Do that before you move. Get that checked. Do the vertex and the graph. And then I